Okay guys, so this video will run through the muscles with you, which is a pretty big chunk of the notes here, but I think this will help as you try to dissect. Basically, we're going to be looking at muscles that you could feel on yourself. There's really hundreds of muscles, but we're just going to learn the main key ones that are kind of easier to identify. Remember, there's three types of muscle out there in terms of tissues. You've got skeletal muscle, which are those large muscles that move the body. Remember, these are voluntary, and they're very strong, and they're very quick in terms of their contraction. Cardiac is muscle of the heart, so we will see that later, but not really having different types to identify. Remember, it's also strong and fast, but it's totally involuntary. And then your third kind is smooth muscle. Again, we'll see that in the digestive tract. Remember, it's very different. It's involuntary. You don't have to think about digestion, and it's weak, and it's sort of a rhythmic thing. For this muscular system information that we're really worried about, we're going to be focusing on the skeletal muscles. And I don't think I need to tell you that that's not really my body. Okay, so the muscular system, in terms of the voluntary piece of it, is a whole bunch of muscles that move your joints. That's really all it comes down to. Now, muscles have two ends to them, right? A start and a finish. The point at which a muscle begins is generally less mobile, and it's called your origin of the muscle. And then the point that the muscle attaches to the more movable part or more mobile part is called your insertion. So every muscle has an origin and an insertion. And the muscles are attached to bones via connective tissue bands called tendons. And I think that's a term you're probably used to hearing. Now, the body has many types of joints, first and foremost, before I really talk about what the muscles do. There's lots of types of joints. We're just worried about two of those, two big groups. And the first big group are called synarthroses, and these do not really move at all. And so the best example of a synarthroses are the sutures of the skull that you see up here. These are fully fused together in an adult, but they are actually still considered a joint because at one point that they were separate bones. Now, the other big group of joints are the ones that you probably think of more, and these are called diarthroses. These are joints that are specialized to involve pretty much free movement. So they come in different types. You've got a saddle joint, which is like your thumb. So if you play around with your thumb a little bit, you'll notice it can kind of move all kinds of different ways. But at the base of your thumb, you've got a sort of saddle-shaped joint. So if you think of sitting on a horse saddle, and you could kind of like lean over and fall off either side of the saddle, that's kind of what your joint looks like at the base of your thumb. Then you've got hinge joints. Those are like your elbow and your knee. These involve a bending but shouldn't involve a twisting. Right? So it makes them a hinge. Then you've got pivotal joints like at your neck, where you can pivot your head pretty much 180 degrees from left to right. And then you've got ball and socket joints, and these are your hip as pictured here and your shoulder. These should involve free range of motion up to pretty much 360 degrees. So just like you can swing your arm around in a circle, your shoulder allows you to move in that full range. Now, when we talk about joints and the way they move, we have some general types of movement, and this is something that maybe you've heard if you had anatomy, but otherwise not something you're real familiar with. These are the major types of movement that we want to worry about. There's a lot of other ones too, but these five will really knock out most of what we're talking about. Flexion, or muscles called flexors, will decrease the angle between parts. So, classic flexion is, let's say you were going to reach up and scratch your nose. Okay, if you flex at your elbow joint or you flex your forearm there, that means you're going to decrease the angle between your upper arm and your forearm, so you're flexing that joint. Then the opposite of a flexion is an extension. So if you extend a joint, or if you have muscles that are the extensors, they will straighten limbs back out, so they will increase that angle. So if you hold your arm straight, you bend it so that you reach up and touch your nose, and then you straighten your arm back out, you have flexed and then extended that elbow. Now, you've also got a trickier pair called adduction with adduction and abduction, abduction. Now, the adductors with a D move a limb toward the midline, and we'll give an example of this here in a second with a picture, while abductors AB move the limb away from the midline. So just like flexion and extension, these are sort of like equal and opposite movements, but they move the limb toward a midline or away from a midline. Then your fifth type doesn't really have an opposite version, and that's rotation. So you can rotate a part around a midpoint, and you can generally rotate in either direction. So here's some really cool pictures. This lady looks like she's really awesome. A couple examples of flexion, and so like we said, you could flex here at the arm and bend the arm up or extend. They're showing you flexion of the entire arm, would mean to pull it up forward. And then she's showing you here flexion of the lower leg, so you're bending that knee joint and shortening it. Then if you look over here, this is the extension of that lower leg. So we make this angle tighter by flexing, and we make this angle wide again by extending. Here's rotation. She looks like she's weird and possessed here with her head going all different directions. And then sometimes too we have something like the leg. You can rotate the leg, as it shows you. If you rotate it laterally, it means you turn toward the outside. If you rotate medially, it means you turn toward the inside. And then you have this whole adduction, abduction thing. So again, remember last time it said, or the last slide said, adduction with a D means you move the part toward your midline. So if you kind of have your arm raised and you bring it back down toward the midline, that's adduction. Abduction, B as in boy, is when you move your arm away from that midline. So it's not really a joint that can flex or extend, or that will flex or extend, but it moves things to and from, or toward and away from the midline. Now, when we dissect on Wednesday here, or Thursday, depending on which class you're in, the skin will be gone already. Okay, so now our job is to carefully remove some of the connective tissue and the fat that is still on the outside of those muscles, because what we want to be able to see are the actual muscle fibers, and we want to be able to see a muscle itself. As you'll notice, a lot of these muscles kind of run together, and what I want to be able to see when you do your checkpoint quiz is each muscle separated out. Now, the connective tissue that we're going to see casing or covering all the muscles is called fascia, and so there's a lot of that on there. It's really easy to tell from fat once we get going what fascia is and what is actually just fat. The only place that you got to be careful in these first couple days is you're going to see just a kind of a ball of fat and maybe some fur even left in the anal region. Now that's because these mammals, just like most mammals, like your dogs at home, have anal scent glands, which can be really stinky, and if we would happen to puncture those, it's going to smell really bad, and we don't want to do that. So you do want to be careful if there's a little bit of fur or a pad of fat there around its butt. You just want to kind of leave that alone. So here's a picture from your book that shows you sort of a side view or lateral view of a mink with a whole bunch of different muscles highlighted here. If it doesn't have any kind of highlighting on it, don't worry then. We are not going to worry about that muscle. But these ones that I've put stars next to, or boxes, all of these are ones that we are going to be identifying here in these notes, and then in your lab book, and then of course on the mink itself. Here is then a ventral view of the belly of the mink. Again, this mink would be supine, laying on its back. And there's some more muscles that we've got highlighted here. Some of these are the same as that last picture, but some of these are different because we couldn't really see them on that lateral view. And then here's human, right? So obviously we are different. We have a little different setup, but many, if you were to look here, many of the same names appear on both, because we actually have a very similar musculature, both being mammals. Okay, so start in the abdomen, or the belly. First muscles there, really easy to find, are called the external obliques. The external obliques are the outer muscles of the abdomen. they run obliquely, which means at an angle from the dorsal area where they originate, so on your back, to insert around your ventral midline. So when we look at you or your mink, you're going to see a line right down the belly called the linea alba. The linea alba here on this picture would just be right here, right down the middle of the pecs. This is a connective tissue seam, basically, that runs right down your ventral midline. The external obliques are going to run from your back around your body, and they're going to attach there in the midline. So here is a label for the external obliques. There are these fibers you see running like this that come around from the back. So these are going to be really easy. They're right at the surface there on your mink. Now you also have what are called internal obliques. And internal obliques are deep to the external obliques, so they're just under the externals. Now these are the inner muscles of the abdomen, and basically what we're going to have to do is poke a little hole in the external obliques so that we can see the internal obliques underneath them. Now these will have fibers that run perpendicular to the external obliques. So on this picture, we don't really have those internal obliques being shown to us, but they basically are going to have fibers that run kind of like this inside there, like my green lines here, versus what the outer ones do. The other muscle that you'll look for, it's pretty easy to find here on the abdomen, is called the rectus abdominis. This is your abs, right? So if somebody talks about having a six-pack or whatever, they're really talking about their rectus abdominis muscles. These originate down here at the pubic area and on that pubic bone, and then they insert up here at the ribs. But they are your six-pack, so they are on either side of the linea alba, and they're usually segmented by connective tissue like you see, so you can get this six-pack look or whatever. Okay, then if we move up to the chest from the abdomen, you've got the pectoral muscles, known as the pectoralis. You've really got two sets here. You've got a pectoralis major and a pectoralis minor. Now what you notice here is this is sort of like cut away. So the pectoralis major is your big pec muscles that originate on the sternum and attach over here on the arm. So if you flex your pecs, you're going to move your arm forward. These are, on the outer part here, the pectoralis minor is deep to the pectoralis major and sometimes a lot harder to find, but they're underneath it there. So the pectoralis major, a much larger muscle, and the function of the pectoralis major is to flex and adduct the arm. So it can flex the arm, which means to move the arm forward, and it can adduct the arm, which means to move your arm toward the midline of your body. Now then you've also got what are called intercostal muscles, and intercostal muscles are found between each of your ribs. So basically all we got to do here is we got to dig into the mink until we find ribs, and the muscles in between those bones are going to be the intercostal muscles. Now we think that these help you breathe, but really scientists don't know exactly what the intercostal muscles do. It's believed that they help move the rib cage a little bit, but there's not a lot of motion there. Okay, so we'll keep kind of moving anteriorly here toward the head. The next muscles that we'll look at are of the head and neck, and we are really just looking at major ones here because there's a ton of muscles up here on your face and things. But the first big one is the sternomastoid, which is right here. This forms a V on the front of your neck, or the ventral surface of the neck. In a human, it's called a sternocleidomastoid, and that's just because it inserts differently than it does on the mink. But on the mink, it's called a sternomastoid, and here's where the name comes from. It originates on the chest at the sternum, and it inserts on the dorsal cranium. So it basically runs here at the bottom of this mastic region, the mouth region, and then attaches on the back of your head. Now, when the sternomastoid on one side flexes, it will flex and rotate the head, which means to flex your head means to bend your head forward, like to touch your chin to your chest, and then to rotate your head is to turn it to the side. So if my right sternomastoid contracts, that's going to cause me to turn my head actually toward the left because it's going to pull across my face basically, or pull across my neck. We can take a look at that motion in class. Now then you've got two muscles that I want you to know of the face and head. The masseter here is a huge muscle, particularly in the mink, that is sort of like your gum chewing muscle. So if you lock your jaws, you'll feel it bulge there at the corner of your mouth. Or not the corner of your mouth really, but back on your jawbone more. This causes a bulge over the angle of the jaw. It is attached to the zygomatic arch, which helps make your cheekbone, and it inserts on the mandible, that lower jawbone. This will elevate the lower jaw, so in other words, this will cause your mouth to close. This muscle is really strong in mink and other carnivores because it allows them to clamp onto their prey and not let go. So if you have a dog at home and you ever play tug with that dog with a toy, you can appreciate the strength of the masseter, which they're able to just clamp down and not let go. I also want you to be familiar with the temporal muscle or temporal muscle. This runs from the midline of the skull down to the mandible. So it's basically from the top of the head around the side of the head to the mandible. This allows, in humans, this really doesn't do a whole lot for you. Helps you make some facial expressions. Is oftentimes the cause of headaches actually. But in a carnivore like a mink, this is huge because this also helps to allow them to lock their jaws and have some crushing strength to their bite. So as a carnivore, it's important for that. These are both pretty easy to find on your mink. You'll want to try to remove some of the fascia or the connective tissue so you can actually see the muscle underneath. But they kind of stick out. They're pretty big. Now to the muscles of the back and the shoulder. The latissimus dorsi are referred to as the lats a lot of times if you were like hanging out at a gym or something, which I clearly do not do. But the latissimus dorsi is this large muscle that originates along the spine, so kind of like here, and then wraps around to insert on the ribs and also on the humerus. So this back muscle sort of comes around and attaches to your arm, and that's its major function. It will extend the arm, which means kind of pull the arm behind you, and it will help to adduct the arm. So it'll also bring the arm closer to the midline, helps the pectoralis in doing that. But the big thing is that it extends your arm. So this big back muscle will allow you to bring your arm back behind you. Second big back muscle is called the trapezius. And in a human, this is the muscle that makes up the kind of side of your neck. This originates on the upper spine here, and then inserts on the scapula. So it's called a trapezius because it has sort of a triangular shape. Now you got one on either side. In a human, for us, it's a single muscle that kind of fans out between the spine and the shoulder blade. Allows you to extend your neck or kind of put your head back. Also adducts the shoulder, so that if you were to try to like pop your back by pulling your shoulder blades back behind you, that's your trapezius. In the mink, it's a little more complicated, as you see here. There's three separate parts to the trapezius. There's the spino-trapezius, the acromio-trapezius, and the clavo-trapezius. And that's determined by what they're actually attached to here. And basically, we're just going to be able to know that it's in this general area, and you'll be able to point to trapezius for me. It's a whole lot easier to find in a human. Now, in terms of the shoulder, there are several muscles in there, but I just want you to know the main one, which is your deltoid. So if you can, touch your upper shoulder and you feel like a large, dense muscle there on the very top part of the upper arm, that's your deltoid. This helps to rotate the humerus or arm and also flex it. And so when we mean flexing it, we mean like raising your arm up. That's what your deltoid muscle does. Now again, this is really easy to find in a human and much more difficult to find in a mink. It's a whole lot smaller. It's actually considered two different pieces, the acromio and the spinodeltoid. we will find one or the other in your mink, and that's what you'll point to for your quiz. But it's a much, much smaller muscle than what we're used to seeing in the human. And part of that is because they use their forelimb so much differently. Now, the last thing you got to know about the back and the shoulder is what we call the dorsal muscle group. If you kind of smack your back or you hit your back, you'll notice that, man, it feels solid, but there's really not bones there. So if you reach around behind you and feel right in this area, it will feel totally solid, but it's actually just muscle. You've got sort of a deep, solid mass of several different muscle groups arranged in several different layers that help keep your back strong. And just the fact that we walk upright should help you appreciate how strong your back really is. And so we're not going to worry about all the different groups there. We're just going to call that the dorsal muscle group on your back. Now to the upper arm, a couple muscles, maybe the most familiar sounding muscles to you are your biceps and triceps. Very specifically here, you got to be careful. You got to make sure you know this brachii part. So triceps brachii and biceps brachii, or sometimes said brachii. Brachii or anything brach means arm. So you have biceps and triceps, but you got to be careful and make sure you say it's the arm ones, right? Biceps brachii and triceps brachii. Triceps is the back of your upper arm, right? The dorsal surface of the upper arm. It originates on the scapula, so it originates on the shoulder blade. Has 3 different heads up there, hence triceps, and then inserts at the elbow on the ulna. And so this muscle extends your forearm. So to stick your arm out straight and straighten your elbow is the job of your triceps here on the back of the arm. The biceps brachii is on the ventral surface of your upper arm, originating at the radius of the elbow and inserting then on the scapula, the front part of the shoulder blade. This is what flexes your forearm. So if you contract your biceps, that's going to bend your elbow. And that's the classic muscle that you flex if you're trying to look tough or whatever. Now, the forearm is really, really complicated, but simple for us. Okay, so you've got many different muscles, as you can see, with really ugly Latin names on the front and back of your forearm. If you go to med school, you can learn all those. Otherwise, we're going to refer to them as the flexors and the extensors. Right? So the flexor muscle group are going to be on the inside of your forearm or on your ventral forearm, and they will flex your wrist and fingers. So if you flex those muscles on the inside of your forearm, that means that you are bending your wrist and kind of bringing your hand in, right? Forming a fist, sort of. The extensor muscle group then are going to be on the back side of your forearm. And if you contract those, that's going to extend your wrist and fingers. So that's like you're going to open your hand all the way up and give somebody a high five or something like that. And that's all you got to know about the forearm, even though it's way more complicated. Now to the hip and thigh and legs, and we'll be finished. The anterior thighs, or the upper thighs, have a really tough covering of fascia that actually has its own name, which is the fascia lata. Now, the fascia lata is a tough covering to that thigh that you're going to have to kind of remove before you can find all those deeper muscles in there, because there's several muscles that are there. This is great for us, though, really. It contains sort of a thigh compartment, which makes those muscles work all together really well, which makes that one of the strongest areas of your body for all mammals. Now, once you get rid of some of that fascia lata, we'll kind of work our way around the thigh. The first one is the biceps femoris. So we had our biceps brachii in the arm, biceps femoris here at the femur or upper leg. This is a broad muscle. It is on the dorsolateral thigh, so kind of on the side toward the back of the thigh, running from the hip and then inserting here at the knee, basically. This is one of the hamstrings that you can pull if you are an athlete, and this will abduct the thigh, which means kind of cause you to move your leg out away from the midline, and also it helps to flex the lower leg, so to flex that knee and bring your leg up as part of this biceps femoris. Second muscle for the hip and thigh is the butt muscle, which we're all familiar with, I think. called the gluteus maximus. This is your major butt muscle. It originates on the fascia of the anterior thigh. So kind of like the front of your thigh is where this muscle attaches, and then wraps around and inserts on your lower vertebrae, like we see here. Didn't mean to move that thing. So it attaches here in the lower vertebrae and forms your butt muscle. Your butt muscle is there to extend your femur. So it actually, if your leg is bent, so think about like you jump over a hurdle and then you extend your leg back out. So you straighten your leg back out. Your butt muscle helps you do that, and it also helps to support your pelvis and just keep your balance and things as well. Then if we move around to the front of the thigh, or so that ventral surface, or what we call the anterior thigh, you've got what's called the quadriceps femoris. Now, it's called the femoris because it's on the femur, and it's called the quadriceps because it has 4 pieces. It's technically 4 muscles, but we usually just call it the quadriceps femoris or the quadriceps group because they all work exactly the same with each other. These originate on the femur or pelvis up at the top here, and then actually pass through the kneecap or through the patella to insert on your tibia. So when you see your knee there, your kneecap is actually encased by the tendons of the quadriceps muscle, and then they all attach just on the underside of your knee. This really powerful muscle allows you to extend your leg, so straighten your leg. If you think about kicking a ball, most of that force comes from the quadriceps as you extend your lower leg as it meets contact with the ball. Now, here's all the 4 muscles that make up the quadriceps, but you don't have to know those specific terms. You just got to know that all of this is your quads, which are also really commonly injured by people and stuff too. So front of your thigh, quadriceps. Now, as we look sort of in the groin area, I guess you could say, so sort of the internal, more medial area of your thigh. If you kind of just flare your leg out, you got 2 big muscles in here. The sartorius is more toward the top of the leg. Okay, and it's this one. And the sartorius originates at your pelvis and inserts at the kneecap and tibia. This does all kinds of stuff, as you see it. It adducts the femur, so it brings it back toward the midline. It helps to flex the femur, so to raise your leg, helps to rotate the femur, and it also helps you to extend your tibia, so it helps you to extend your leg and do that kicking motion. The gracilis is very similar to the sartorius, but it's more toward the bottom of the leg, I guess you could say. So it's more dorsal, and it will help to abduct the leg. So gracilis, the way it contracts, will help you move the leg toward the midline there, or away from the midline, excuse me. Last thing, I think this picture's funny, I don't know why, but the last thing that we want to look at on the upper leg is the back of the leg. There's a muscle called the semitendinosus. Now, this is the most posterior of the thigh muscles. It's the very back of the leg. And this is sort of the primary hamstring that humans pull sometimes when they're exercising. And this is also what we call the tenderloin in a lot of animals that we eat, like a beef tenderloin or pork tenderloin. That's the semitendinosus. Now, this originates at the pelvis and lower spine and inserts down on the tibia. And so it just runs here right along the back of the leg. This will help your leg to flex, meaning that if you're going to raise your heel up towards your butt, that's the motion that the semitendinosus helps you do. Now, the last muscles that you need to know are the muscles of the lower leg and the foot. This is a little bit more detailed than the muscles that we learned of the forearm, where we just said flexor and extensor, because these are much larger and easier to find. The first one is the gastrocnemius. This is your major calf muscle. So this is on the dorsal lower legs, the back side of your lower leg. This originates up here at the femur, so actually above your knee, and then attaches via the most famous tendon of all, the Achilles tendon to your calcaneus, or to your heel. The calf muscle is what helps to extend your foot. So if you want to point your toes, the gastrocnemius is contracting, and it causes you to point your toes like that. Now, the kind of opposite muscle, so gastrocnemius is your major extensor for your foot. Your major flexor for your foot, so if you wanted to sort of bend your foot, bring your toes up towards your knee, is called the tibialis anterior. And it's a tricky sounding name, but it's exactly what it sounds like. This is attached to the tibia, and it's on the anterior part of the leg, so it's on the front of the leg, right? And this originates on the upper tibia and fibula, runs down the lateral length of the tibia, and attaches to your foot at the metatarsals. And this allows you to, again, like raise your foot or flex the foot. If you feel your shin, you're feeling your tibia, and then if you run your hand down sort of the outer or the lateral side of your shin, it should feel much softer, like soft tissue, and that's the tibialis anterior that you're feeling out there. So notice, in the human it's easy. In the mink it's going to have a different location kind of, but there's your tibialis anterior, and there's your gastrocnemius. Now you've also got other flexors and extensors, both on the lower leg and on the foot, but we don't have to worry about those for our purposes. So that's all the muscles. I know it's a lot. You'll have quite a bit of class time to work through these with your group and try to identify them in the mink. I hope that you found this video informative and helpful as you look through your notes. See you in class.